Alright, I figured I'd make a video for the zone here. Finally have basically finished up the work on the belt drive conversion for my PM25 mill, and so far I'm really pleased with what I've got. So basically what this involved was taking a part that Scott Starlipper on CNC Zone made, and he made this integrated pulley and drive spline, and also made the motor pulley back here for a belt drive conversion he was going to do, and I think he ended up going a different direction, and I was able to snag these parts from him. So what he's got going on with his pulley system is he basically took this part, which is the old gears, the shaft that held the bearings and gears, and remanufactured it to include a set of pulleys on the top. And in addition to the pulleys, he also integrated the RPM ring. I don't know if you can see it down here, but yeah, you can kind of see my sensor back there sitting in its normal location, and then got that little ring going around with the holes cut in it so that it can read the RPM that the spindle's turning at. So all one unit. It keeps the quill operation, although I've got a little question for him later on. But you can see I can still lower and raise the quill. I get up and shut the whole thing. Tough to do. This iPod camera. Alright, so there we go. I can still raise and lower the quill. There was a C-clip that held the spring, the return spring for the quill inside here. I'm at a total loss how I would get that C-clip back in there. So the only thing right now holding the spring in is this screw-on cap. And it definitely reduced the spring pressure for the quill so it doesn't pop all the way back on its own. You have to kind of give it a nudge to get it all the way home. I think I can work around that. Or a little work on the lathe, and I can make a part that pushes that spring down a little bit further, gives me back the tension. But overall, works pretty well. Keeps my quill intact, so I can do some occasional drill press duty. So getting this guy out was not an easy task. I followed Haas's video from his DVD on the belt drive conversion, and did basically the same thing he did. Used some 1/2-inch thread to get me a nut that I could place on this guy and tap it out. Took a lot of tapping. It was in there very tight. My original idea was that I was going to replace these, take these bearings off of this shaft and just put them onto my replacement shaft. That did not go. This top one I could not get to come off no matter what I did. I mean, I pulled on it with bearing pullers. I used heat, cold, pounding, trying to use inertia, you know, smacking it down on some wood, and just heating, cooling. Nothing would get this bearing off of here. I don't know if they've got some adhesive that was on there. I don't think they do. I think it was just a really tight fit. This bottom one did eventually come off with a bearing and gear puller, but in the process of originally trying to get it off, I pretty much toasted this one. So I went ahead and just used a gear puller and pulled it off however I could get it to come off, and with as much pressure as I needed to do. Top one I'm just going to leave in place. I'm just not going to mess with it. I'll leave it on there. If I ever have to return the mill to gear operation, I can. I'll just have to get a lower bearing. So what I ended up getting was some Nachi bearings. You can see the top ones now in place up here. They weren't really terribly expensive. The shipping was twice what the bearings were just to get them here, and I shipped them overnight so I could get back to work. Otherwise, I guess I'll just go ahead and fire it up and let you guys see the thing in operation here. I did have to make some modifications here, sorry, for Haas's. I originally made this for Haas's belt drive conversion. Scott's pulleys are set much higher, so I had to make some extensions for the side rails, and then I also, I don't know if it's going to show up on this video or not, had to cut some pocket back there so that I could put my RPM sensor back in place where it was. I like it. That means it's kind of nestled back in there, protected, and you can just barely see it here. I cut a little bit of clearance into the base so that RPM sensor could slide underneath there. So those are the main modifications I made to the parts I already had in place. Eventually I want to make some new rails because I don't really like the idea of this belt flying around at 5,000 RPM, right basically at face level. If anything were to, the thing were to cut loose for any reason, I really would prefer that it not come flying straight at my face. So I want to make up some kind of guard that goes in front up here. But we'll go ahead and fire it up here. So head over forward. Alright, so right away, this setting used to be about 700 RPM on my old setup. You can see I'm getting about double that at the same setting. Alright, so I would say probably right about there was what my old maximum RPM was. Even when it was, if it was completely warmed up, it would hit about 3,200. You couldn't cut at that speed; it would bog down more than that. But it would hit this running free. So we'll go ahead and crank her all the way up. So running cold, I'm getting about 52. As it warms up, it'll run a little higher than that. But 52 is where it'll start off cold. I think reasonably probably about 5,000 is going to be the max. But totally changes the character of the machine. I can stand here and talk to somebody at a normal level of voice, and that was absolutely impossible before with the geared system. It was entirely too loud to do that. That was at 3,000 RPM. At 3,000 RPM, this thing's almost whisper quiet. I will say that early on, I do notice that if I crank it all the way up to the absolute max, I will see a little bit of fluctuation. It seems to kind of it'll kick up a little bit high, and then it'll slow down a little bit, and then it'll kick up a little bit more. Eventually, once it all warms up, it'll run at a higher speed. But I think we're probably reaching the edge for what it wants to do. I imagine we probably hit the top end of the motor anyway. It's pretty easy to slow it down by hand on the spindle. So I mean, I don't think it's going to have cutting torque to do really, mammoth cuts at this speed anyway. So, but that does give me a lot more leeway than I had before with the 3,000 RPM. So I'm pretty stoked about that. It'll be nice to see what we can do with some actual cutting. So we'll go ahead and switch it to the low gear. Allen wrench out here. I'm just going to loosen this guy. Sorry, I tried to do this one-handed. Loosen up that motor. we go. So one of the other changes I had to make was originally I think we bought 15-inch belts for a Haas's conversion, and this one needed a 16-inch for me to actually be able to use the range of the adjustment on here. The 15-inch was too short. I could just barely get it wrapped around with this guy pulled all the way forward, so that wasn't going to work. We'll go ahead and fire it up now on the low gear. So right about in here is about the limit of how slow I can get it to go. It's very easy to stop the spindle with it running that low. It will eventually pull out of your grip, but not without racing up a little bit, and you could definitely stop the spindle a little bit too easily. So I would say probably your realistic low end to actually do anything is probably around 300. At that speed, it actually has some torque to fight against me, and it's racing a little bit. I'm going to have to play with the adjustments on it to see if I can get it to keep a more constant RPM under load. But for right now, it's on, it's turning. It's been 4 days of lots of work to get to this point, but I'm pretty happy with what I've got so far. So we'll go ahead and crank it up to the top end under low gear. And with it fully warmed up, I'm getting about 2,900. So very close to what my old maximum RPM used to be on the low gear. If later on down the line I wanted to play with the speeds a little bit, I can always remanufacture that motor pulley and change the ratios a little bit to either try to get more low end torque or maybe a little bit more top end speed. I don't know what, but I'm pretty happy with what I got at this point. Let's see what it does with actual cutting. So that's my converted machine, and get some new rails cut for it, and call it finished.